So we were discussing SN1 and SN2 mechanisms. Now let's do a few reactions based on that. Question: convert 1 bromopropane to propan 1 or convert 1 bromopropane to propan 1 or. What is 1 bromopropane? That is CH3, CH2, CH2, CH3, 1, 2, 3, 4, bromo. And to that, you have to mix 1 propan 1 or. 1, 2, 3. 1 bromo, 1, 2, 3. 1 bromo propane to propan 1 or CH3, CH2, CH2, OH. This is 1 bromopropane and you have to convert that into propan 1 or. What to do? Change that we are saying is Br is replaced by OH. Aqueous OH, Br is to be replaced by OH. So what you have to do? KOH, you take KOH, put water, and K plus and OH minus are to be separated by putting water. By putting water, K plus and OH minus will be separated. And then OH minus will be replacing this Br. OH minus will be replacing this Br. So, what you have to do? This arrow mark, this is a single step reaction. So, on this arrow mark, you can write aqueous KOH. Aqueous KOH. Which mechanism that you don't have to write SN1 or SN2? What mechanism it will undergo? This is primary, so this will be SN2 mechanism. SN2 mechanism it will undergo. Okay, next question. Convert propene to propan 1 or. Convert propene to the same thing, that is propan 1 or. What is propane? Propane is an alkene with 3 carbons. So 1, 2, 3. Propane in CH2, CH3. Around carbon there should be 4 balances satisfying. So 3 plus 1, 4. 1, 2, 3, 4. 1, 2, 3, 4. Around carbon 4 balances are to be satisfied. So here, this is in and we have to convert it into or. This one we could convert Br to OH. Br to OH. That's a single step reaction. Now here, can you make a Br here? You can do by doing HBr peroxide. You do HBr peroxide. So I write here CH3, CH double bond CH2, HBr peroxide. So you will be getting 1 bromo. Hydrogen of the hydrogen halide will be added to 4 hydrogenated carbon. So CH2 will become CH3 and halogen will be added to less hydrogenated carbon, that is Marconic acid. Now in presence of peroxide, anti-Marconic acid will be formed. That means hydrogen will be adding to hydrogen of the hydrogen halide will be added to hydrogenated carbon in presence of peroxide. If peroxide is not there, then Marconic acid. Peroxide is considered, so in peroxide, then anti-Marconic acid, that is hydrogen of the hydrogen halide will be added to less hydrogenated carbon, while halogen will be added to hydrogenated carbon. So here CH3, CH2, CH2 Br. So we have reached here. We have reached here. Now what can you do? Now you put at SQH, you will get that propan 1 mole. So this is a two-step reaction. So I'm writing here that is at SQH. CH3, CH2, CH2. You get propan 1 mole. So are you thorough with organic chemistry? The checking is how? By checking whether you can do conversions. So take a refresher and go through the conversions. As we proceed, more and more conversions will be coming. So for organic chemistry, you should have a refresher. Or exercise questions also contains conversions, equations, reactions that you should go through. Next, ambident nucleophile. Here, OH minus is a nucleophile. A strong nucleophile can replace a weaker nucleophile. Stronger one can replace a weaker. If it is Cn, then Br can be replaced by Cn minus, KCn put in water, K plus and Cn minus is the nucleophile, that the nucleophile is stronger than the Cn minus can replace the Cr minus. So you'll be getting a cyanide. Next, ambident nucleophile. Ambident nucleophile, Cn minus. Cn minus has got two nucleophilic centers, carbon and nitrogen. Similarly, NO2 minus also has got two nucleophilic centers. We say ambident nucleophile. Cn minus, that is Cn. How will we write this Cn? We'll write the Lewis dot structure. That is carbon, outermost electrons 4, nitrogen, outermost electrons 5 plus minus. This minus means 1 electron extra. That means 10 electrons, 10 electrons, 10 electrons. Minimum 1 both should be there between the 2, 4, 6, 8, 10, 10 electrons are out. So here carbon is not having 8 electrons. We are pulling 1. Again 2, 4, 6 only. So we are pulling again 1. So this is triple. Now all are having 8 electrons. Now this carbon, it should have 3 bonds around it. The number is less, that means it carry a minus. So this is the state of Cn minus. Now I am putting this electron pair. Carbon is having an electron pair. It can use this electron pair to attack. Nitrogen is also having an electron pair. Can attack by that electron pair. Means from both the sides this attack is possible. Means it is an ambident. It is an ambident. Again, NO2. Nitrogen has got pair of electrons. Both the oxygens are having pairs of electrons. Now, which will attack? Both can attack. If both attack at a time, then you will be getting different products. Okay. So we are going to see with the sign. When carbon side attacks, then the product is called alkyl cyanide. If nitrogen attacks, then the product is called alkyl isocyanide. If nitrogen attacks, then the product is called nitroalkane. If oxygen attacks, then it is called alkyl nitrite. Alkyl. So let's say we are taking CH3, CH3, this is our halo, and I'm putting KCN and AgCN. KCN is ionic compound. By putting in water, it will get dissociated into K plus and Cn minus. If Cn minus, so from here actually attack is by Cn minus. C can attack or N can attack, but if C attacks this carbon, a CC bond will be formed. A CC bond is more stronger than a CN bond. So this is the product obtained, that is methyl cyanide. Is this cyanide? Cyanide. Now in the case of AgCN, the bond is not ionic like this. This is covalent bond. Since covalent bond cannot be broken easily by putting in water. So only nitrogen can attack. Carbon is in connection with carbon side is not free. Carbon is not free to attack because it is in bonding with Ag. But nitrogen side can attack. Nitrogen has a pair of electrons. When nitrogen attacks, then nitrogen will be forming a bond with carbon. So the product will be N. Then slowly this bond will be broken and coming that side. So this is isocyanide. Isocyanide. Now what about NO2? Here again I am taking CH3Cl and KNO2 and AgNO2. AgNO2, that is the bond here is bond KNO2 in the sense K plus O N O. O N, this much portion is minus. This much portion is minus. Here, Ag, that is O N, then O. This one is O minus, and I write this one. Electron here, electron here. Then N O. So here, on putting in water, this plus and minus will get separated. O minus will be attacking the carbon and CH3 alkyl like CH3O NO. CH3O NO. You don't have to show that other electrons. Now here, this bond cannot be broken and this bond cannot be broken. Now, nitrogen is there, oxygen is there. Both are nucleophilic centers. But oxygen is more electronegative. Then less electron, oxygen cannot give electron. Now here, nitrogen is less electronegative, oxygen is more electronegative. Oxygen will not give electron. Nitrogen is less electronegative as compared to oxygen, so nitrogen will be making a bond with carbon. So CH3, then nitrogen will be making a bond with N, double bond O. Here O, slowly this will be breaking and coming. Here O minus, like nitrogen is having already a plus sign because around nitrogen there are 4 bonds. So that one is alkyl nitrite. Alkyl nitrite. While this is nitroalkane. Nitroalkane. Alkyl nitrite and this is nitroalkane. Okay. So with the same nucleophile you are getting different products. Same nucleophile. Cn. One is alkyl cyanide, this is methyl cyanide, and this is methyl isocyanide. And with NO2, the connection is here O. Then alkyl nitrite, this is nitroalkane. So that's about the ambivalent nucleophile. Next we are going to the Next, we are going to the stereochemical aspects of SN1 and SN2 reaction. In SN2 reaction, there is inversion of configuration. In SN1 reaction, there is inversion as well as reduction. SN2 reaction, there is inversion of configuration. And in SN1 reaction, there is inversion and reduction. Right? Now, if you are starting with a substrate in which carbon is attached to four different groups, such carbon is called asymmetric carbon or chiral carbon, which is connected to different groups. Carbon is connected to fluorine, chlorine, iodine, bromoiodine. This carbon is an asymmetric carbon or chiral. If you take its mirror image is not superimposable on the mirror image means carbon F, Cl, Br, I. Its mirror image is not superimposable. What is meant by non-superimposable? Okay, my left hand is the mirror image of right hand. When I keep this on this is not superimposable. Means thumb and small finger, then ring finger and pointing finger. Only this middle finger is matching. Here again, ring finger and pointing finger. Here thumb and small finger. So they are non-superimposable. They have a special property, special physical property that is called optical activity. Optical activity means when a plane polarized light is passed through this, what is meant by a plane polarized light? Ordinary light has got vibrations in all directions perpendicular to the position of its path. When such a light is passed through a nickel prism, all other vibrations are cut off except one plane. So you will get vibrations only in one plane. So such a light is called plane polarized light. If this plane polarized light is passed through this compound taken in a test tube, the plane of this plane polarized light, either it will be rotated to the clockwise direction, means your clockwise direction, my clockwise direction is like this, that is like this, clockwise direction, or it will be rotated to the anti-clockwise direction, like this. Okay, I don't know what side it is coming, clockwise and anti-clockwise, you see. My clockwise may be your anti-clockwise. So, when such a compound is taken and kept in a polarimeter, that machine is called, that instrument is called polarimeter. Polarimeter, it is standing like this. You take the test tube and this compound in that test tube, this liquid, and put that test tube inside this. So if this is the test tube. Okay, and you pass this light through that test tube containing that compound. If the plane of the plane polarized light is rotated to the clockwise direction, that means towards the right, then that compound is called dextro. Its mirror image then will rotate the plane polarized light towards the left when we call it rotate. Suppose you mix these equal amounts, same composition, equal amount, and you mix and you put in the test tube and see the left rotation will be cancelled by the right rotation. Then you will see the plane polarized light switch. So, this is a chiral compound. If it rotates the plane polarized light towards right, we call it as dextrorotatory. Then its mirror image will be rotating the plane polarized light towards left. That is in the anti-clockwise direction. We call it as wavy rotate. A mixture of this will not rotate the plane polarized light. That mixture, an equimolar mixture of these two things, 50-50, that is called a racemic mixture or racemic modification. Racemic mixture or racemic modification. Okay, we are going to apply these things in SN1 and SN2 reaction. Chiral carbon is also called asymmetric carbon. Chir means handedness. Chir means handedness. Chir means handedness means its mirror image won't superimpose on the object image. Object mirror images are non-superimposable. So that dextrorotatory is called plus isomer, laboratory is called minus isomer. Both are called enantiomers. Enantiomers. Enantiomers are non-superimposable object mirror images which are non-superimposable on each other. Enantiomers are object mirror images of a compound which are non-superimposable on each other. Chiral carbon, that is a central carbon, which is also called the stereo center or asymmetric center or asymmetric carbon. Asymmetric center or asymmetric carbon. If a compound contains one asymmetric carbon, the compound will be optically active. Means it may either rotate the plane polarized light, or it is PPL, plane polarized light, either towards right or towards left. Then we have to find out by putting inside that polarimeter to check its optical angle. So we are applying this to SN2 mechanism. SN2 mechanism. You are starting, suppose you are starting with a compound, four different groups, one is CH3 and one is H and one is CH2, CH2, CH2. We are not giving a CH3 here. CH2, CH2. And here, Cl. We are giving that OH minus. In SN2, there will be inversion of configuration. So here, C6, C6, H13. So inversion of configuration C, CH3, H. Then here, C6H13. Inversion of configuration takes place. Here, OH. If this is dextrorotatory, suppose this is plus isomer, and that will be labor because inversion of configuration takes place. This plus changes to minus due to the inversion. That is minus isomer. Both are called enantiomers. One is dextro, one is labor. In the case of SN1, inversion as well as reduction take place. So here C, CH3, then C2, H5, then what? 1 H. Four different groups are going to 4 different groups I'm going to put it. And here OH minus aqueous KOH or aqueous NaOH. What will happen? Retention as well as inversion take place. Retention as well as inversion take place. So one compound will be rotating. Suppose this is plus, you will be getting here plus and minus. Equimolar mixture of plus and minus. That mixture is called racemic mixture. You write the plus and minus 50-50. This equimolar mixture of plus and minus isomer, that is called that racemic modification or racemic mixture. Thank you.